some common limits involving infinity. So the first set here, we're going to look at two that exist. So limit as the input goes to plus infinity of 1 over x to the n. Here n is some positive number. This is going to be 0, and this one is said to exist. The other one is limit as x goes to plus infinity plus. This one is e to the minus ax. A is some parameter that's also a positive number. This is 0, and it also exists. Bit of an explanation why. So if n is a number larger than 0, then this is the you're dividing 1 by some number that's getting bigger. It's important that this n is larger than 0 so that this stays as a positive value in the denominator. What happens is, as x gets big, you're dividing 1 by bigger and bigger numbers, and so it's going to eventually flatten out for you. Similarly here with this is x to the n, approximate graph of that, with e to the ax, so you have an exponential curve here, but because you have the minus sign, it's going to flatten out there and get really small very quickly. So those are two limits with positive infinity that exist. Let's look at some with negative infinity. These also exist. Limit as x goes to minus infinity. This one, again, x to the n. You need to be careful. N has to be positive. You also want n to be an integer. Otherwise, you're dealing with complex numbers and this gets a bit more complicated. But if this is an integer, then this is a real number. And again, you're just dividing by some power of a big number, and so it's going to drop off. And because we're talking about negative infinity, this time we're looking at this side. This was e to the minus ax. This is still 1 over x to the n. It could be on either side of this, depending upon if it's even or odd. But in general, but the important part is we're really looking at the far field behavior here. And the other one, again, a greater than 0, limit as x goes to minus infinity. This time it's e to the ax. Note the sign here. This time it's positive, and then you have the minus sign there. And so this one is 0, this one is also 0. Because it's positive, this time you have your exponential curve looking like that, and because we're looking at this area, it's going to go to 0. So these are a couple of common results that you want to be aware of when you're evaluating them. So just so you really shouldn't be computing much. You might want to graph it if you have to, but these are ones you should try to remember and memorize.